In lesson 5.9 here, we're going to look at complex numbers, which also involves imaginary numbers and the imaginary unit. So let's just consider this here for a second. It says consider the equation 2x squared. Consider the equation 2x squared plus 2 equals 0. If you solve this equation for x squared, the result is x squared equals negative 1. So what they're talking about there is if you actually subtract 2, you get 2x squared equals negative 2. You divide by 2, you get x squared equals negative 1. So since there is no, so if you tried to do the square root now of both sides, like you've learned so far in math, okay, there isn't a real number square root of negative 1. So since there is no real number whose square is negative 1, the equation has no real solutions. So French mathematician René Descartes proposed that a number I be defined as I squared equals negative 1. This is called the imaginary unit. I squared is equal to negative 1. So we're going to be using that in this lesson. You need to know that. The imaginary unit I squared is equal to negative 1, which thus means that I is equal to the square root of negative 1. So two things you should write down in your notes that you need to remember are those two things. Okay? So a question to ponder, and we'll hopefully answer this as we go through the notes in the lesson here. Which one of these is right? Okay? We know that the square root of 3 times the square root of 3 is the square root of 9, which is 3. But how about if there's negatives underneath? Okay? Is the square root of negative 3 times the square root of negative 3, do I just multiply the negative 3's underneath and get this so that my answer is a positive 3? Or does it really come out to be a negative 3? We're going to hopefully answer that question for you in this lesson. Well, we will answer that question for you in this lesson. Okay? Alright. So, first of all, we're going to look at simplifying square roots when we have negatives under there. Okay, so if you look at this first one, and again, remember these two things, I squared is equal to negative 1, and I is the square root of negative 1. The imaginary unit, I, and that's why we use the variable I, is the square root of negative 1. Okay, so we end up with imaginary answers here. So what you need to do, whenever it's a negative that we're trying to simplify under the root, we want to think of this as the square root of negative 1 times the square root of 28. Okay, because we need to take care of this negative sign right here. Okay, now the square root of negative 1, by definition, is I. Okay, so we know we're going to have an imaginary, non-real solution to this. Okay, you still need to simplify the square root of 28 just like you did with simplifying roots. I need to find a perfect square factor. Well, that's 4. So 4 times 7, square root of 28 simplifies to 2 square root 7. So the square root of 28, just showed you the work there, is 2 square root 7. Now, and this is multiplication here, how do we bring this together? We multiply this. Now the I is not under the root, so I need to multiply this out in front of parentheses. I is kind of like a variable, and we want to write that second, so I'm going to write it as 2I square root 7. So the square root of negative 28 is the imaginary number 2I square root 7. It's a non-real answer. Okay, so now we want to do this over here with the next one. We have the square root of negative 32 y cubed. I want to break this down into the square root of negative 1. Again, that's taking care of the negative sign. Times the square root of 32. Okay, now I'm going to do, and then times the square root of y cubed. Square root of negative 1 is I. I'm going to simplify the square root of 32. I'm going to do it up above here. What perfect square goes into 32? 16. So it's the square root of 16 times the square root of 2, which is, I don't have a lot of room there, so I'll come over here, 4 square root 2. So this simplifies to 4 square root 2. Square root of y cubed. Okay? I want to break the square root of y cubed down into the square root of y squared times the square root of y. Okay, because I can't divide the 3 by my index of 2 right here, like we did earlier in this unit. Okay, the square root of y squared is y, and then I still have a y underneath the root. So the square root, y squared is a perfect square. What you need to do now is you need to kind of bring everything all back together. So I have these two and this not underneath the root. So the best way to write that is 4y and then put the I before the root. So usually the imaginary unit part we put before the root, and then what's left under the root, we have the 2 and the y. So that's what goes under the root, and that would be your answer. Okay, now it would not be wrong to write it 4iy. Usually you're used to writing things alphabetically. Usually we put the I after any other variables and obviously the coefficients. Okay, so that's the best way to write it. All right, multiplying pure imaginary numbers. Simplify each expression. So, if you think of this, if I had negative 3x times 2x, so imagine they weren't i's or that imaginary unit. Well, what do? You multiply the negative 3 times 2, that's negative 6. X to the first times x to the first is, okay, and that would be as far as you could go algebraically if they were x's. So you're going to do the same thing here. You're going to get negative 6, I to the first times I to the first is I squared. But remember that I squared is equal to negative 1 by definition. So I really have negative 6 times I squared is negative 1. So it's negative 6 times negative 1, which ends up being 6. So my answer to negative 3i times 2i is 6. Okay? If you are multiplying square roots of negatives, you can't just do this. Multiply and say, oh, that's a positive 24, and then simplify the square root of 24. If there are negatives involved, which there are here, you have to pull out the square root of negative 1 or the i's first. So what I'm going to do is I'm going to break this into the square root of negative 1 times the square root of 12. And then I'm going to break this one into the square root of negative 1 times the square root of 2. I'm going to get this out of there for right now. All right, so this is I. This is also I. Okay, so keep those in mind as we continue. And now I want to break down or simplify the square root of a positive 12. Well, that's square root 4 times square root 3, or 2 square root 3. So I got to keep that in mind as I get my answer. And I can't simplify the square root 2 part. So everything that I've circled there is what I have to bring together for my answer here. So how do you write your answer? Okay, now notice I have I times I. Those two together are I squared. But what's I squared? Well, let's write it this way first. Let's write it as 2 I squared. Okay, is outside the root. Now I have square root 3 and square root 2. So I'm going to bring that back together and I'm going to multiply the things that are under the root. So that's going to be square root 6. Okay, but what is I squared equal to? By definition, it's equal to negative 1. So this really means 2 times negative 1 times the square root 6, which is equal to, we're going to actually multiply those two, negative 2 square root 6. And that would be your answer to that problem. Simplifying powers of I. The results, there's 4 results you can get when you have I to any powers. Okay? You can end up with 4 possible answers. Either I, negative I, 1, or negative 1. So we can end up with I, negative I, 1, or negative 1. When you just have I to some big power. Okay, and I'm going to show you, we're basically looking at 4 examples here. We'll kind of look at the 4 different scenarios you can have. Okay, we want to keep in mind that I squared is negative 1 by definition. Okay, so keep that in mind as we go through these. If on the first one we have I to the 35th, that starts out as an odd exponent. What you want to do is you want to break it down into I to the 34th times I to the first. 1 less than that exponent. Now you want to take I to the 34th and you want to write it as I squared to some outside power. Now remember, when it's a power to an outside power, we'd have to get I to the 34th. So that's going to be I squared to the 17th, and then that's multiplied times I to the first, and I'm just going to write that as I here. I squared is negative 1, so I have negative 1 to the 17th power times I. So it's I squared to the, or negative 1 to the 17th times I. If you raise negative 1 to an odd power, means I multiply negative 1 together an odd amount of times, that's going to be negative 1, and then I have times that I. Well, we really just write this as negative I. So that whole thing simplifies to negative I. All right, let's look at a different odd exponent, I to the 57th. So I want to kind of start out the same way. I to the 56th times I to the first. Now I want to do this as I squared to the power to a power 2 times what is 56? That'd be 28th. Okay, times I. So this is really negative 1, because that's what I squared is, to the 28th power, multiplied by I. Now over here, we had negative 1 to an odd power. Well, that was negative 1. Negative 1 in parentheses to an even power, you're multiplying negative 1 together 28 times, would be positive 1. So it'd be 1 times I, or just I. So when you have an odd power, you're going to either get negative I or positive I. Okay, let's take a look if powers start out even. Okay, now I don't have to break it down because it's not odd. I can just go right into writing I to the 64th as I squared to the 32nd power. Well, I squared is negative 1, so it's negative 1 to the 32nd power. Like we did here, when negative 1 was to an even power, that is going to equal positive 1. So we don't get an I on our answer. We get positive 1. Okay, now you probably realize the next answer is probably going to be negative 1, but let me show you why. Okay, we got an even exponent to start with, so that's I squared to the 21st power. Well, that's the same as negative 1, because I squared is negative 1 to the 21st power. When you have negative 1 in parentheses to an odd power, your answer is negative 1. And those are the only 4 scenarios that you can get when you take I to a power. Okay, equation with imaginary solutions. So what we're going to do is we're going to solve this. 5y squared plus 20 equals 0. So if you solve this, because there's not a y squared and a y term, you can solve this algebraically. Okay, you don't have to do it, it's quadratic, but you can do it algebraically because you don't have a y to the second and a y to the first term. Then you have to do it either by factoring or quadratic formula. So we're going to do it by algebraically or by undoing. So we're going to subtract 20. So 5y squared is equal to negative 20. Next step would be divide by what's in front of y squared. So y squared is equal to negative 4. Now we're going to take the square root of each side. Okay, so we get y equals, now remember when you take the square root, you need both a positive and a negative root. Okay, now square root negative 4, that's like the square root of negative 1 times the square root of 4. What we just learned is the square root of negative 1 is I, so it's equal to I times the square root of 4, but let's go ahead and 4 is a perfect square, so that's I times 2, or 2I, right? We want to put the 2 in front of I because that's a variable. So basically your answer is y is equal to positive and negative 2I. The square root of negative 4 is 2, and then we have to have the I on there because of the negative sign. So y equals positive and negative 2I would be your answer there.